explain about the query native dataset. Yeah, so this will be like you can see the different why DataFrame do like that way that we has discussed previously, and then why the query native dataset is in the different approach. Yeah. Okay, I will share to continue the materials. Okay, for querying native dataset, actually the issue is like real world pipeline. In the real world pipeline, often extract data from, this is the very unique heterogeneous sources. We need to run a wide variety of algorithms from different programming language, programming libraries. Yeah, sometimes we using the Flums, yeah, and then somehow we using the Storm or something else in the big data, or maybe we can just access the API of for example of Twitter's, yeah, and maybe if you have our own IoT environment, we need a IoT platform to communicate with the source of data. So very heterogeneous sources. So it's very difficult if we do that one. It's mean we need one sources. We will need one spatial pipeline to serve that one. So that will be very difficult. So that's why in the Spark SQL allow user to construct data frame directly against RDDs. Yeah. So that's why if we want in the using the normal way, it's mean we do the pipeline using the data frame that we discussed previously. But if we have, for example, not only just Hive, but maybe we have another database with different type of database and then we need to collect the data, to query the data in the same times, yeah, because we do the big data processing, so we not just let all the data in the same data set, but somehow we need a lot of data sets. So we have to do a new way, not only as previously. So this is will be interesting because we in the Spark SQL is also allow us to construct data frame. Still we call data frames, but directly against RDDS. Yeah. Of course, it will be the object native to the programming language. Yeah. For example, in the Scala and Java, type information is extracted from the language type system. Yeah. And in the Python, samples the dataset to perform scheme inference. Yeah. And Python is dynamic type. Yeah. So this is like the example how we do this one. So in here, I think you will be a little bit confused because somehow when I discussed previously, we explained about DataFrame API inside the Spark SQL. In here, we discuss data frame, but actually directly to the RDD. Yeah. So in here is you can see the form of difference because in here we need to state the case class, yeah, users, and then we describe about the data type, yeah, and then this is very unique because we need to create an RDD of user object, yeah. In here users RDD, yeah, and then we call the Spark parallelize, yeah, and then we need to list the user if we from the user class in here. So internally, Spark SQL create a logical data scan operator that point to the RDD. So it's like just skip the data frame API from the previous directly to the RDD, yeah. And then the view we need to view the RDD as data frame. So you can see in here the RDD can be a tools to create the data frames, yeah. Because in here we have a function like user df as user RDD to df, yeah, compile into physical operator that accesses field of the native objects, yeah. And if we have a combination with the external structured data, so yeah, of course, we can combine like this one. Yeah. So you can see in here, we can view from the tables, yeah, and then join, and we can merge 2 or 3 or more data source into one single data frame. So that's actually I call the overkill capacity, overkill facilities that bring by the Spark. Yeah, because if we run it into, like, for example, using the common engine like Hadoop itself, we still need to define in very step-by-step process to define this combination. For example, when I want to merge the txt file from the IoT log, and then will be merged with the table-based data from the database of the information system, for example, that consists of location and so on. So it's very difficult. So, but and mostly we will do the ETL process to make in one data set in the same structure, and then we can run to the HDFS. But in here you can see we doesn't need the ETL actually. The ETL will be replaced by this one, yeah, by build the data frame. Yeah. So it will be very important to us to know. And then you can see in here, showing user entity with table in Hive. So it's very interesting. So if you, for example, I invite you, if you like, if you doesn't have any idea for your bachelor thesis, I think this point is very interesting to explore as your master of your bachelor thesis. For example, we can bring, like, if we have, like, today, if we have in university, in our university, we have semester, we have a lot of information system in there, but mostly to gather the information inside the system, we still need to depend on the query base that query to all the databases. And all query will be served by one query one by one. So it will be very complicated. I don't know if inside there we have a microservice or something, but if we can imagine we replace by the big data environment, will be more easy to combine it, and then every data without any resources to to define the data set that with the common structure, for example. Yeah, so that will be the very interesting one. Yeah, so that will be the interesting one. And the interesting one again is the Spark SQL. It's like process all that kind of process in the in-memory caching. So they very incentive on the memory resource usage. So that's why when using the Spark, most of the data center or engine or machine will be allocated with the the appropriate capacity of memory. So they will need this because, yeah, most of the data frame operation is using the cache hot data in memory, yeah, and using the columnar storage. So that's why it's very very consuming the memory of in the server, for example. And then cache simply stores data, yeah. And then in the Spark SQL columnar cache can reduce memory footprint, yeah. And then especially when we do the iterative algorithm like machine learning, we will do the caching process in many ways, in a very iterative way. So that's why we came up with the very intensive of processing. So somehow that will be make the machine hot, and then need attention to handle. Yeah. So that's why in here very important to have like a big data DevOps engineer to optimize, and then to to make the server more efficient. Yeah. So that will be very interesting. And then invoke by calling catch on data frame. Yeah. So that's why, because it is need to handle the huge of memory usage. So that's why we need a catalyst optimizer. Yeah. So if you still remember about the concept of functional programming, actually it's very simple. Yeah. why we're using the functional programming? Because functional programming gives us flexibility and capability to handle the programming purpose based on the functions. Yeah, actually, maybe about 4 years ago, or 3 years ago, I teach the functional programming using the Haskell, if you still remember. But that's for the native programming language, yeah. But for today, in the big data environment, we have Scala. Scala is like Java or maybe Python, but using the Scala, the functional programming paradigm for develop some application or method. Yeah, this is extensible design because easy to add new optimization technique. Yeah, feature to Spark SQL, enable external developer to extend the optimizer. Yeah, and actually inside the Catalyst, yeah, we call the Catalyst core contains a general library for representing trees and applying rules to manipulate them. Yeah, so Catalyst optimizer is like collection of general library that used in the in the operations, yeah. And because it's general, so that's why is like as catalyst, yeah. Is facilitate the need of the computation purpose, yeah. So in the catalyst optimizer, on top of the core, especially consists of library that specified for relational query processing. Yeah, using like expression, logical query plan. This is will be very common in the library, inside the library, and several set of rule can handle by query execution, yeah, like analysis, logical optimization, and then physical planning, and also code generations. Yeah, this is also uh, inside the Catalyst optimizer. And of course, several public extension point is also included, like external data sources and user defined can be added in the Catalyst optimizer. Yeah, this is the in the core of the Catalyst optimizer, the library. Yeah, and we also have the Catalyst tree. Yeah, this is consists of the main data type. The tree will be composed of node objects. Yeah, and each node has node type and zero or more children. Yeah, so it will be like 3 node, and new node type are defined in Scala as subclasses of the 3 node class. Yeah, this is will be immutable and can be manipulated using functional transformation. So that's why this is the approach close with the functional programming. Yeah. Yeah, so this is the 3 node actually. So you can see in here in the figures, it will be represent the tree. The 3 node will be have a literal consists of value of the data type as constant value, and then we have attribute can be the name, maybe for example string will be explained about an attribute from input row, and also on the add will be the 3 node. Yeah, we have two kind of 3 node, can be left or can be right, and then sum of two expression. So that will be the 3 node classes. Yeah, so this example class can be used for expression. Yeah, and because the expression will be represented as add, yeah, attribute, add literal, and etc. So that will be the concept of catalyst trees. Yeah, actually, catalyst tree is one of the main, main point on in the functional programming. So if we learn about functional programming, we divide the function into several sub-functions. So if we want to, for example, to do the functional of reading, so it's mean we need to first take a look the books, open the books, and then etc. We have a lot of tree on here. And then, of course, the tree can be not only just tree, but we need the roles, yeah. Because catalyst role is function is to manipulate the tree. How the tree works is based on the roles. Now, a function from a tree to another tree. Yeah. So it will be arranged by the rules. Yeah. And we have a common approach on here. Use a set of pattern matching function that find and replace subtree with a specific structure. And in Catalyst, tree offer a transform method that applies a pattern matching function recursively on all root if the tree. Yeah, so transforming the one that match its pattern to a result. Yeah. So this is like the rules. Yeah, tree transform. So we can have a case and then add the literal of the tree. Yeah. So yeah, we have this one. Okay. And the catalyst rule will have a pattern matching expression. Pass to transform is a partial function. Only need to match a subset of all possible input in the trees. So so that's why in the optimize, so that's why it's called optimizer, because we have a lot of rule to optimize the process based on the tree. Yeah. And Catalyst will test which part of tree given a rule applies to, and automatically skipping over and descending into subtree that not match. So it's just like the Spark have like a capabilities to learn the process, and then will skip when they found it's not match. Yeah. In practice, a rule may need to execute multiple times to fully transform a tree. Yeah, it's like a machine learning, I think, literally algorithms, yeah, transform a tree, yeah, until it's reached a fixed point, until we get the point, yeah, the tree stop changing after applying its rule, yeah. So this will be rule-based, I think, rule-based machine learning, maybe something like that. So we generalize in a random way, I think, yeah. Okay, that's the clue. So yeah, this is the catalyst in Spark SQL used in for passes, analyzing logical plan to resolve preference, and logical plan optimization, physical planning, and then code generation to compile parts of the query to Java bytecode. Yeah. So this is like when we have SQL query and data frame, we go to the unresolved logical plan, and we will do the analysis, and then we have the catalog in here, so we do the logical plan. After that, logical plan will be optimized by logical optimization, and then we have the optimized logical plan, and then we do the physical planning, and then we have the several physical plan, and then the cost model, and then we select it, and then after that we have the RDDs. So long way to RDDs, but more optimized than previously. So in the performance way, the difference between data frames and RDD will be seen here. In RDD, more complicated actually, because not only just framing the data, but also try to optimize the frame into the good performance. Yeah. And then this is the catalyst in Spark SQL analysis. It will begin with a relation to be compute, yeah, from abstract syntax tree, the AST, will be returned by a SQL parser, and from a data frame object construct using the API. So that's why in the Spark, the API will be most common method to deliver the data frames. I think. And then the relation may concern unresolved attribute reference or relation. For example, in select, yeah, or from maybe sales, for example, and the type of the column or even its valid column name is not known until we look up the table sales, yeah, and we decide as unresolved. Yeah. And Spark SQL use catalyst rule and catalog object that track the table in all data source to resolve this attribute. Yeah. So this is will be very important in the catalyst in the Spark SQL. So you can see in here about catalyst optimizer, one of the small component in the Spark SQL is very long to explain. Yeah. So because it's very it's very interesting to explore about it. This is apply standard rule-based optimization to the logical plan. I think this will be like very important part of the of the of the work on the catalyst, yeah, because it include constant folding, yeah, predicate push down, projection planning, null propagation, and Boolean expression simplification, yeah. So that will be our include in the catalyst. Yeah, you can see in here actually when we learn about this, you can feel that the different approach on the programming process here. For example, when maybe before you learn about big data, you only know about the it's functional programming, and then we only know about procedural programming and so on. But in here you can see a lot of optimization, a lot of parallelization that implement to enhance the capacity. So that's actually the heart of big data. It's not only just big data on the volume of data, but also how we process the data is in the different approach of data. We try to enhance the capacity and the quality of the data processing with enhance the current procedure that exists in the way. Yeah. Okay, so that's will be the logical optimization. I will stop before continue to another explanation. Yeah.